that the population of left-handed individuals in Enugu urban is not just 20. Is this true? Yes. They are not only 20, but because we have grouped into clusters, so the clusters have become our size, population size is what? 20 in this scenario. That's clear. So since the population size is now 20, what do? We will come to these 20. And supposing we are interested in only 3 locations in Enugu, which location did we use yesterday? We selected One Road, New Heaven, and Juari. So out of 20 of them, we selected only 3. Exactly. So in this case, our population size, which we have used, is just what? 20. That's understood. So in this case, it does not require that we know the actual population size. The actual population size is what? The population of left-handed individuals in the water. Is it not our population? That's the population of our study. Yes, we don't need to know what the entire population is. We are working with what? The population of the clusters, which is 20. And that becomes our population size, which we are going to use for the what? For the selection. So when we have selected our sample size at this point is what? 3. Is that understood? So if you have selected these 3 clusters, which is our sample size, we will now go into 3 clusters to begin to look for what? All the left-handed individuals in these 3 clusters. Whatever is the number, maybe at the end we want the number to be 500. That becomes our sample size. Is this understood? Is it clear now? Yes. Right. So I want to quickly having you remember we said that sampling or sampling technique are further divided into 2, which are probability sampling and non-probability sampling. We mentioned that yesterday. What we have discussed so far, they are all probability sampling methods. I want to quickly look at the non-probability sampling methods. Is that clear? It is not in the slide that we showed this. It is important that you mention that. And what makes a sampling method to be non-probability? We agreed yesterday that the probability sampling methods or techniques are those techniques where all the individuals, all the units have what? Chance. I didn't say we call chance, so that we have a chance of being in the sample. In all that we discussed yesterday, it was only one method that today that all the individuals have, and that is the sample. But in probability sampling, all the units have the chance of being selected, no matter what is the magnitude of the chance. Some may have higher chance, some lower chance. But what is the difference is that all the units have what? Chance of being selected. That is the probability sampling. Now, look at sampling techniques. There are sampling techniques where all the units have a chance. In other words, there will be some individuals, some units that are not candidates of selection at all. Is that understood? So whenever we are carrying sampling, and we have determined and excluded some individuals to be part of our participants, it means that we are being good. We are conducting non-probability sampling. Is that clear? No. And there are different techniques under non-probability sampling methods. One of them is what we call convenience sampling. Convenience sampling. And what is convenience sampling technique? Convenience sampling technique is a sampling technique where a researcher selects individuals who are readily available or who are readily accessible. You understood? You are studying a particular population Just like we have mentioned here yesterday, we are carrying out a study of the entire of any program, and I want to use sampling. In- Maybe I examine for research, and I'm doing sampling of what? Feeling water, which will some maybe to include people from New Haven, for instance. And I'm going to use a sample size of 300 for the study. Is that clear? I will ask myself, assume again that this study is on children, which means I am expected to do what? To get participants that will cover the entire of the program amongst the school children, and which requires that I will be going from school to school in the entire of the program. Is not understood. And because I decided I have one alone, and I will look at the inconveniences of visiting school actually, and I will tell myself that what I'm there to do, I can accept visit the schools in Abu the road and get my participants. Do you understand me? And as a result of that, I will decide, let me stay at Abu and I will invest myself because I can see the number of children, good children in Abu. In fact, more than 300. There are thousands of school children at Abu. And I will go the next 300 and I will 300 of them such. It understood. That is the convenience sample. I can tell you by convenience, and it will be difficult for me to begin to travel from one place of any program to the other in search of participants. Where I have them readily available number of groups, so I will do so. So in such a situation, we could what? Convenience sample. That is one way of another way of explaining convenience sampling. In the same research that involves school children in any program, there may be some school heads that may not be friendly. I don't know if you understand that. Because you cannot just get into a school and begin to use the children, the school children as the participants without clear words, permission to do that from the school head. And you have looked at it, there are some school heads that are not going to be maybe very friendly. And because of that, you remember that one of maybe your mom's friend somewhere is a school head. And they have told their mom about this, and the mom calls her friend. And the friend said, no problem, just you will just run to that school. You have what? A ready to use the school children there. I hope it's understood. So you go there and then get your participants. That is convenience sampling. It's understood. So by doing so, any school where you have a school head who is going to or who is likely going to give you trouble of any kind, the school has been what? Excluded from the study. So you will never get any participant from such a school because their school that you got is not friendly. I'm sure you understand. So that type of sampling is confidence sampling. The next one is purposive sampling. The purposive sampling. Yes, from purposive sampling. And what is purposive sampling? It has another name, which is called judgmental sampling. It has another name, which is called judgmental sampling. And what is purposive or judgmental sampling technique? In this method, the researcher chooses units who possess certain characteristics of interest to form the sample. The researcher has decided I want to use certain type of individuals for this my study. I'm sure it's understood. And as the researcher is moving about looking for participants to be recruited for this particular study, there are certain persons the researcher will see. This person doesn't possess the characteristic ability and the study. And as a result, is what? Excluded. I'm sure it's understood. Is it understood? And because of that, the researcher decides before he begins to recruit participants for the study on the kind of persons that he wants to use, not the ones that alone are not supposed to be used for the study, but even the ones that are supposed to that are part of the operation. The researcher, because of the characteristics he has formed, he will not want to do what? Improve them in research. And as a result, the researcher has purposely decided on the kind of participants that he wants to recruit for his study. In such a situation, it is a judgmental sampling technique or a positive sampling technique. I'm sure it is clear. It's very clear. Now, the third one is what we call quota sampling technique. Quota sampling technique. And what is quota sampling technique? It is just from its name, quota. You are studying a population and you have decided that you know this set of people, it is their time to be used. They have the right to be used at this point. Just the way maybe there are some elective positions, they will say that you can what you quota system. Nonetheless, that if it is not your turn, even if you are the most qualified, are already what? Disqualified because it is not the tongue of whatever is the means of the division, what is understood, means of certification. If it is not the tongue of these people, so we already excluded. Is that understood? In such a situation, it is important something that in this study, for instance, you are carrying out a study on school children and you have decided that even though it is all the school children, that is maybe other studies, but in this particular time, I want to use 3 children. That's understood. As though it is their turn to be used. And as a result of that, if you are not implemented, you are what? Excluded from this research. So in such a situation, that is happening technically. The next non-community sampling technique is what we call volunteer sampling technique. Volunteer sampling technique. And what is volunteer sampling technique? The recruitment of participants is dependent or lies largely on the words, on the style of the participant, the population. We have given up of them, we have made it available with anyone that has interest to be used to study, then the person should indicate. And it will be those that are interested that will indicate. You understand? And in the situation, it is possible, even when you are studying the heterogeneous population, it is possible that all the people that have interest will come from one strategy. And because of the fact that they are interested, what do you do? You recruit them as their participants. So that is volunteer system sampling technique. Then the next one is consecutive sampling technique. Consecutive sampling technique. And what is consecutive sampling technique? It has another name. And this name is the first come, first serve sampling technique. First come, first serve sampling technique. Maybe I want to carry out a research on undergraduate students at the Faculty of Health Sciences of the University of Nigeria and Sudan. I want to conduct a research and I want to have 100 participants. And maybe I will go to somewhere there one morning and understand as I see those students as they come, I will be recruiting them. I will continue to recruit until I get 100 participants. Since my sample size is 100, so the moment I have got 100 of them, what do? I will stop. I have got even if those 100 I have recruited, maybe they are coming from somewhere with a very good course, and the course is stopped, and all of them lined up, and we recruit all of them, and they are coming out arriving from the course. Once I have got the 100, whether I represent, it's probably to all the people that come from one department. Maybe they went for excursion. One department went for excursion, and I saw them as I have recruited them. What I do is that I'm studying this faculty. Wherever they are coming from is not important to me. I hope it's understood. In such a situation, we are not considering spread. We are not considering representation. We are considering results. As you see, good. So that is consecutive something. And the last I want to mention is what is called the snowball sampling technique. Snowball sampling technique. And what is snowball sampling technique? It's a sampling technique where few units are selected are free to recruit additional units from their peers until the needed sample size is obtained. This type of research is usually done when one is doing research. There are some research that one is going to be sensitive and secretive. For instance, you want to look at maybe people that are into substance abuse. For instance, I don't know if you are getting what I'm saying. And you know that people cannot readily say that are into substance abuse. You understand? Until they succeed in getting maybe still in any problem. And they are studying this group, and you want to have the sample size to be confident. You may succeed in getting 4 persons who are into substance abuse. And you play with them. They know they are members. Is it not so? Yeah, you play with them. Please bring your members. You need to, I want to have 100 of them. Then we go to the various groups and then they help invite their members. You are not maybe addressing, you know, this kind of research is sensitive, and you will need to seriously address the participant for the participant to agree to be into the study. You understand? Yes, instead of how are you going to see them address them? If you see only 5, you will talk to those 5, address them, and give them the assurance that you are using a unique academic purpose, and the identity is not going to be known or seen in any way. You understand? By doing so to them, you will now tell them, please, we need about some kind of people. They have to get their members. They will be the that will not be recruiting for you. What is understood? In this situation, until they will continue to make their members until they have them. Once you have your program, you are good for study. This is what all of them are not ability and I'm sure it's understood. There is major advantage of non-sampling, non-probability sampling techniques. All of these techniques I have mentioned, they have one common advantage. And what is the common advantage? It is easy, very simple to go by. I hope you understood. This is the common advantage of non-probability sampling techniques. All of them are very easy, very simple to go by. But at the same time, all of them put together. Now, one common major disadvantage. And what is that major disadvantage? In all of them creates selection bias. All of them introduces bias to the selection. So that is a major problem of non-sampling technique. I'm sure it's understood. So having said that, that's about non-sampling techniques. You have a question? You have a question? Okay, 1, 2. Okay, try.
Okay, thank you so much, sir. Just a quick one.
Yes.
As you have mentioned the disadvantage of all of them have one major disadvantage of creating bias in selection.
Yeah.
Please, can the results be generalized? Can they be generalized to the major for them?
Okay. The answer to the question is yes. We are studying the population, and any result we are getting is for the population. We don't carry research for sample members. Do you understand? Whenever we are involved in a research that has to do with sampling, that research is about a given population. The essence of going into sampling is because we will not be able to get to all the units in that population. So whichever way you recruit, whichever way you get your sample, the reporting is still for what? For the population.
Because of the bias.
Yes.
The bias is it for the individual thinking that they were not selected, they now feel
No.
it's for you.
No.
For you, is it for you?
Not even for you, it is for the study.
Yes.
The study has a selection bias. Is that understood?
Yes.
But not minding that it has a selection bias, you may still decide that even though this has a selection bias, maybe I am constrained to use this sampling method. That is one. Number 2 is that you have discussed and you have agreed with your supervisor, and your supervisor permits that you should go into that. No problems. But in terms of bias, the data study has a selection bias. That is very clear. But at the same time, it does not invalidate the results you are going to get can still be reported. You understand? But even while you are reporting it, someone else that is reading it knows that there is what? Chances of what? Biasness in this thing that you are presenting. Is that clear? Next person.
My question is, I want to clarify the difference between complex and total sampling. For example, you went into a secondary school and you wanted to do Igbo classes, but the JSS3 students and the SS3 students are on the exam in this period. Would you say that the sampling you use is complex or total sampling?
You said that you want to use JSS3 students?
The whole class.
Yes.
But unfortunately, the JSS3 and the SS3 were currently writing exams. So you now had to limit as well to the non-exam classes.
The non-exam classes. As at the time you are doing the research, like I said, the company sampling is when you are making use of what is available or what is easily accessible. So in this case, these other ones we are already having an exam, maybe they are being restricted. In such a situation, you just decide, okay, let me use the ones that I can easily see. That is convenient sampling. I don't know how I've been trying to pick one example I can use for data sampling. Let's assume I want to use this. Maybe it may be somehow, maybe derogatory somehow, but I want to use this example. I'm conducting a research, maybe on patients. And in this research I'm conducting, probably there is maybe something that I have known, that if a patient, for instance, I have known that the body weight of a patient affects this research I'm conducting. Are you getting me? Maybe those that are oversized, big enough, depending on what you mean by oversized, according to your own definition of oversized. You have known that they will not give you. Using them in the study may not maybe give you what you want. That you will need people that are what? That are smaller in size. Do you understand? That is, if it is possible that such a thing exists. But I'm just trying to use it as an example to present to quota sampling. When you go to look for the patients that in that population, the patient that you want to use, once you come across someone that is oversized, according to that predefined definition of oversized, do you understand? You will try to do what? You dodge the person. I will not use this person in this my research. But when you see amongst those patients someone that is smaller in size, this is what a candidate that I want to include in my study. Do you understand? In such a situation, you have decided the kind of people that you want to use, and that's why I say that you have decided exactly what you want to do. So some part of this are not part of the research, while some are what? Candidates for the research. And then finally, okay, exactly it is. Sorry, what I was explaining is judgmental sampling. Sorry about which is actually proposing sampling. In that case, maybe before we leave, I will try to pick one example. But before then, there are so many hands, and you're not permit all the hands. Let me take this one at the back before the person. She will think that she has been raising her hands and I've been bringing down the hands. Now she can talk. How to determine the sample size and how to determine the sample technique. Well, the one that is a problem to us at this point is how to determine the sampling technique. The size is not yet a problem to us because we have not even discussed sampling size yet. So the question is, how do we determine the sampling technique to be used? And the answer to that is very simple. I want to say all of these sampling techniques, they have their pros and their cons. Is that understood? Any particular one that you want to use, if it is maybe research that you are conducting now as a student, discuss it with your supervisor and agree with him. Is that clear? Because each of them have their pros and their cons. But if it is a research you want to do exactly what you are supposed to do, no matter the cost, even when, yes, no matter the cost, in such a situation, since you are studying a whole state, you will first of all know that the first question that will come to your mind is, since it is sickle cell, people that are having sickle cell that you are studying, you will first of all ask yourself about Lagos State as you go. Could there be differences as you move from one area of Lagos State to the other with respect to the particular study that you are conducting? If there is no difference or differences you have seen, what does it imply? What it implies is that Lagos State has become what? That the sickle cell persons in Lagos State have become a homogeneous population. So in such a situation, you can use any of the methods of sampling that is used for a homogeneous population. But if you have looked at it and have identified maybe something that will bring heterogeneity to the study, what does it imply? It implies that you cannot take Lagos State to go as a homogeneous population. You need to first of all stratify Lagos State before you can go ahead with your study. Is that clear? Finally,
when a sample size has been determined, and you go ahead to have selection criteria, and some of them are finally removed, for instance.
Who removed them?
Okay, maybe based on the selection criteria, some of them that should have been in the sample, for instance, uh, will finally not be chosen. Yes. So will we now say that the type of sampling?
You are still hiding some things. You are being economical with words. Why will they not finally be chosen?
Okay, maybe because they did not meet some criteria needed for the study. Okay. Shall we now say that the type of sampling technique has been changed because there is now a selection criteria? Maybe you had in mind of doing a normal random sampling. Okay, now you have determined the sample size, and now again there is a selection criteria. That means it's now tending towards precocive. Shall we now say that the sampling is now precocive, or is it still normal randomization? There is
Okay, somebody wants to help the question.
Yes,
If that is what you will do,
no, this was the question that I wanted to ask.
okay.
Now, when you are giving the example of
Mhm.
who said it was judgmental, I've seen a
No,
study
but
about,
they are not the same.
I know, but I've seen a study, the person who talked about multi-stage sampling technique. The person used a school, shared departments from departments stratified to faculty, the levels. They now said that you use random sampling to pick the respondents for each level. Now, but based on the exclusion criteria, he said he reported that he excluded the people that were repeating class. So the people that were repeating class automatically did not join the study. So that kind of that when you reported it was a random sampling technique. So is this still judgmental based on the exclusion criteria?
Okay. This one is more definite. This question that she asked is more definite than the one he was trying to paint, which even up to now I have not been able to get exactly what you are saying. To address this, what it simply means is that it is not first of all purposive sampling. Why? It is not because those that are repeating class are not going to be included, it makes it purposive. What it means is that they are not part of the study population. You understand? The repeaters are not part of the study population. That is the meaning. So it has been defined that the person is studying people that are in the class, the various classes for the first time. That has been defined. So when they now get to the class, they are now looking, even when they are using simple random sampling, those that are repeaters, they have been removed. They are not part of the study population. That is the meaning. It is important to understand the population that we are studying. Even though we are studying school children, for instance, one may come up with the fact that I don't want to use repeaters. Maybe for some reasons. It is possible because maybe because they have gone through this route before and coming again that it is going to introduce bias to the study I want to conduct. And as a result, I don't want to include them. That has been removed ab initio before the sampling begins. Is that clear? So the study population in this real sense are what? School children who are not what? Repeating. You understand? That is they define the study population. I don't know, is that the same in line with the question that you asked? Let's go into the question and answer. Okay, Do we agree to take that question? Okay. Hold on.
Suggestion, let us all write down our thoughts so that at the end we can start bringing them out so that this lecture can continue.
Are you sure we will have that end?
And
We attend to those questions.
And again, I will also suggest that you should let us know, for those of us who are not aware, that in one study, you can use both probability and non-probability. Apply it in one study. It's not restricted that you must use only one. Maybe only probability. You can use both probability and non-probability. So that
Okay. Going by what he has said, he has introduced something that I did not say. Sorry, this one he said, I am not with him. We can use probability sampling and non-probability sampling. But that is in one study, that is if that study has been sectionalized, where maybe we are interested in looking for two different things in one study. There are such studies where everything I'm looking for that will bring about the holistic attendance to this particular research will require that I will do the first stage, or I will partition it or sectionalize it. I will do this and report it, and do the other one and report that. Is that clear? In such a situation, for this particular segment, I may use probability sampling. For the other segment, I may use non-probability sampling. But if it is one single holistic research, it is one method that is appropriate for it. I just needed to respond to what he said so that everybody here will not begin to go that, okay, you can combine different methods of sampling to study. Maybe I will now decide at this point. Let's take this last question. If you should make it very brief. Yes.
I have in mind to maybe my population is small,
Mm-hmm.
and I have in mind to include all nurses, for instance, in children's ward.
Yes.
And getting to that ward, I discovered that some nurses refuse to collect the questionnaire.
Mm-hmm.
And in my proposal, I've already mentioned that I am going to use total population. Getting to that place, sharing it to maybe people volunteers who that maybe you feel that they are interested. We now change lie and explain the truth. It can even come in ethical committee.
Mm-hmm.
Another example. Maybe I want to use UATH hospital and a particular ward, and I came to collect ethical clearance, and they refuse. And I've already started this work using UATH. Can I now use ESUS? Not changing the UATH I wrote. I'm using that particular, knowing that these are tertiary hospitals. I'm using now using children ward in ESUS to study the children ward in UATH. Why
Okay. Thank you. Sorry. Hello. When as she was asking that question, we have something high. But it is important that we admit these are kind of things we see in practice. And it is important that they are addressed. We may just shout out, maybe how can you be saying that? When you start your own, you will begin to experience it. So these are the things that we see when we get into the field. And how do we address it? My answer to her question is the issue of ethical clearance. If you have gone to, you want to use UNTH and you get to UNTH for maybe ethical clearance and it is turned down, what this simply means is that you will not continue with UNTH. Is that clear? That it then means that you are going to change your study population. And because of this important question that she asked, it is always important at the point of maybe choosing a particular research that you want to conduct. It's always important to check availability of participants. Is that clear? That is one of the preliminary works that is very important that must be done. Sometimes, maybe my undergraduate students they want to do this particular work or that particular work. The first question I would ask is that this work maybe it sounds fine, but how do you think you can get the data? Somebody may say that I want to look at I want to do quality control on the quality variables of maybe Nigerian breweries. Is that clear? Maybe or Coca-Cola company. And it sounds very fine. But the question I will ask is how are you going to get the data? Because Nigerian breweries I know cannot release their quality variables to you. So how are you going to get the data? And that is the beginning point. If you don't have data, there is nothing else you are going to do. Since you want to work on quality control, fine. Look for a company, first of all, where you are sure you can get data from. Has that answered your question? Maybe one aspect of the question. Then the other aspect of the question is you get the place and you have hoped to use the entire population for a study. Sometimes it is possible, but anytime that I'm doing a study and I'm using the entire population, I see it as maybe enumeration. I made enumeration. How do I mean? I cannot include the entire population in the study. And still, first of all, maybe will you be able to use percentages in your work to report it and then end at that point? And you will still say no, that you need to do maybe something like test of hypothesis. Do you understand? So when you have included the entire population in a study, what are you testing for? All the facts are there. Do you understand? Any work that has all the population units included in cannot be subjected to test of hypothesis. So what it requires is when you include the entire population, fine. But when you have got responses, discuss the responses. You understand? And that is the end of such work. You cannot begin to subject it. They say that maybe in my department you need to include something like test of hypothesis in your work. What are you testing for? In terms of hypothesis, we are trying to do what? We are trying to see if something that exists in the population is true or false on the basis of a sample data. You understand? But when you have got that which exists in the population, you have it already. So what are you testing for? What you now need to do is, having got this, discuss what you have got, explain it, and that after the explanation, that is the end of it. That is by the way. Now, when it comes to assuming you have decided to use a particular maybe set of people, and it happens that when you get there, some have declined. If it is actually a research work that involves sampling, if some have declined, there are some that will not decline. Is it not so? So, face those ones that will not decline and get your data from them. I don't know, I've tried to balance the question you asked. Okay. So we will go to determination of sample size. Determination of sample size. In research, sample size determination is always a very important aspect of research. And so many methods have been used for determination of sample size in the research. And I say that a sample is used to study a population. it is important to have n. Small letter n is what we call the sample size. Okay? While capital N is what we call the what? Population size. So, it is important to have the sample size that will be adequate for the study. This is because every study about a population on the basis of a sample from the population introduces a measure of error in the findings. No sample results is error-free. Did you hear what I said? There is no sampling result that is error-free. The reason is because whatever thing that you are saying is on the basis of a sample, you have not So as a result of that, there is need, an obvious need of determining how to do what? How to get our sample size for every research. And in determining the sample size, we will determine it in such a way that we will use an appropriate or adequate sample size that will be able to give us what? The research findings that one can do what? One can hold on to. Is that clear? So the sample size is we use so many things to determine the sample size. I have said before, every single stage that one is going through in research, of course you are going through with your supervisor. Whatever you have agreed with your supervisor, you continue to follow it. I hope it's understood. But what is not correct, I want to say this because I have seen this kind of thing happen in research. What is not correct is that you have agreed to use a sample size of maybe 200, and you now decide, maybe because of resources, let me use sample size of 100. And when I'm reporting it, I will report that I have used a sample size of 200. It is academic fraud. And the fraud everywhere must be frowned at. I hope it's clear. We know that it is possible sometimes that it may be done, but it is fraud. It is a fraudulent practice, and it must be avoided as we go into research. If for whatever reason you cannot get the 200 that you are supposed to use, why don't you discuss it with your supervisor? Perhaps he or she will be able to help. After that, we look for, two of you can look for something to support that use of that 100. You understand? There are so many things that one can use to support something. Maybe you are using this when you are supposed to use 200, but someone somewhere may have done something. Maybe in such a, have met such a situation and the person has stated something. It's a simple quotation that XYZ in 2024 did this kind of work and they stated this. And using that, even though we are supposed to use 200, but we are using what? 100. Whatever thing that you have done, let it be what you are reporting. Is that clear? So, there are three main methods of determining sample size in most of the research works that are done. Number one, which is the simplest, is mere use of simple percentage. I don't know if you have had that before. Someone might say, maybe with an agreement by agreement with your supervisor, okay, since you have this corporation, you can use 10% of the corporation. Do you understand? If you have chosen to do that, state it that that is what you use. There are equally some persons who have used simple percentage to arrive at the sample size they are using. But while reporting, they will begin to search through the literature and they will see one complicated formula. And they will just carry that formula and put in their work. And then they will then try to continue to adjust until it arrives at the sample size they have chosen to use. It is equally what? Academic fraud. Whatever method you have chosen to use it and say that this is what you have used. Do you know why it is important that you report the method of sample that you have, or the method of sample size you have used? Because when you have finished doing that, that may be a gap for another person. Another researcher may look at it and say that this person has used a sample size determination of sample size of this method, and he used sample size of this, and he obtained this result. But if this sample determination of sample size, if it changes, So this other method that the result may not be exactly what it is. And that becomes a gap for another researcher. Do you understand? Don't think that the simple research you are doing, that you are going to cover everything in that area. Nobody can cover everything in one research. Whatever thing that you have chosen to do, be sincere and report it. The lapses, the pitfalls of that particular research may form what? Beautiful gaps for subsequent researchers. But what we try to do is whatever is involved now, let me just write it. Even when it is not what you are doing, all of those things are not academic fraud. And we, of course, we always found at academic fraud because it doesn't help anybody. When you are reporting what you did not do exactly the way you did it, especially for all of you that are in health sciences, any single thing that is reported can go a long way in harming human beings or improving the lives of human beings. And that is why we must be very sincere with whatever thing we are doing. The next method of determining sample size that is often used is what is called the Cochrane formula. And I don't know, I won't be able to maybe show what the Cochrane formula is for determining sample size. But it is, let us just note that it's a method. Cochrane is Cochrane. That is the name of Cochrane. He is one of the founders of, unfortunately, is a woman, and she is one of the founding fathers of sampling theory. She did so many works in sampling theory, and she came up with a method that is known as Cochrane formula. Then, after that, there is yet another formula that is the most popular formula I have seen. I am the one calling it the most popular formula, especially in social surveys. And that is what is called the Yaman formula. The Yaman formula for determination of sample size is very popular among social surveys. And I still will not be able to project the formula. But there is a sharp difference between the Yaman formula and the Cochrane formula. What is that difference? The Yaman formula will require the knowledge of the population size before you can use the Yaman formula. Do you understand that? If you don't, because the formula includes what? The population size, which is capital N. So if I don't know the population size, then it becomes difficult for me to use the Yaman formula. But at the same time, before somebody begins to ask a question, so if I want to use the Yaman formula and I don't know the population size, what do I do? I had explained that before, that one can estimate the population size for a particular research, even when you don't know the exact population size. There are so many indicators that can be used to find an estimated population size. And what are those indications? For instance, something like Nigerian Bureau of Statistics, they publishes maybe yearly population bulletin every year. And there, we know that the last time we did census in Nigeria was when? In 2006. And by 2015, it was already due for another census, but that has not happened even until now. And that, whatever be the case, but the population of Nigeria as at 2006 census is not the population of Nigeria today. I'm sure we know that. They have continued to improve. And what are they using? Maybe in that 2006, they have looked at the birth rates in Nigeria. They have looked at the death rates in Nigeria. When you bring the death rate and the birth rate, you can project the population of a nation, even for the future. And that is what they have been using so many indicators, things, factors that affect population to do what? To estimate the population of Nigeria. And that is why maybe they can say that in Nigeria today that we are over 200 million people. And if you go to NPS to ask them the actual figure of the citizens of Nigeria as of today, they can give it to you. But does it not mean that they have maybe not carried out census again? No, they are doing what? Estimating. And in the same way, we can do what? Estimate the population of um, the population size of our study area. I hope it's understood. If we understand what we are looking at and then the area we are studying and the factors that affect that area, with all of those things, we can estimate the population of that population. And the simplest thing I will do, maybe I'm studying the left-handed individuals in Enugu urban, and I go to one locality. Maybe I have, in that locality, I have a population of 1,000 people, for instance. Out of these 1,000, how many of them have are left-handed, for instance? Maybe out of the 1,000, 15 are left-handed. I go to another locality, still within Enugu urban, maybe there are 500 of them. Out of these 500, how many are left-handed? Maybe 10. I hope it's understood. I go to another place, another locality, maybe there are 700. Out of these 700, how many are left-handed? Maybe 11. What am I now trying to say? If I know the population of Enugu urban, for instance, and I will see the fraction that I have selected from that population, I have a total of 2,000 persons. Out of these 2,002 persons, maybe 36 are left-handed. What do I need to say? If I multiply the number that I have maybe investigated by the number of the entire population of Enugu urban, I can as well multiply the what? The left-handed persons I have obtained. So with that, I will be able to say that the population of left-handed people in Enugu urban is so and so. But when I am using this method to obtain my population size, it is equally important that I put it down in my research that the population of this study area is estimated as maybe 1 million. I hope it's understood. So that whoever that is reading it will understand that it's an estimated population, that we don't know the actual population. I hope it's clear. So, in the Jamel formula, the population size is known, but in the Copeland formula, the population size.
Is it from there? Oh, no. Maybe it should be from there. That guy, let me call.
I hope you can hear me.
Wait, let's call. Let me call.
How do you hear what I said?
Let me call him. Let me call him. Is he there?
Let's continue while the
Don't continue. Don't continue because of those online.
It's all right. So let's. Okay, we can go on now. So I was saying that the Cochrane formula requires not the use of the population size. That is one difference between the two. But I know in social surveillance, the Yamane formula is most commonly used. Okay? And I'm sure, equally sure that you people know the formula. You are not sure. Okay. Okay. Thank God you have something that you are not sure of. And I am sure that what you have is correct. Even when you are not sure, I am sure that is correct. But all the same, I have the formula that by the time the objected slides are shared, I'm sure you will see the formula there and then confirm that it is correct, which I know it is. There are some other authors that try to obtain um, different methods for determination of sample size. And these ones are more complicated, that they are almost very rarely used. And they are methods by these authors, Kirkwood and Stein in 2003. They obtained these more complicated formulas, which are very rarely used. So if you are so much, I won't say so much about them, but if you are interested in those formulas that they came up with, I can refer you to their work, their book, where they presented those formulas. But for all the researches that we are doing, especially now, I'm sure that the methods, the ones I have mentioned so far, that they are very much adequate for the research you are doing. I hope it's understood. So at this point, when we have conducted sampling methods, yes, when we have conducted the sampling, um, it is not for any other thing, but for us to collect information, for us to collect data. So the moment the sampling is done, like I have said, that in sampling survey, we collect, determine the sample, and when we have determined the sample, we collect information from the sample. So the moment that is done, already we have data for our research. Is that clear? So everything that we will now be discussing from this point will be on data. So, having discussed the sampling, which is how to obtain the sample that we are going to use, the next thing now is how do we go about getting information from that determined sample. I know that this is my sample, these are the participants, so how do I get information from these participants? And that's what we'll be discussing now on methods of data collection. And I want to say that there are two main sources of data collection. And those sources are primary source and secondary source. All that I'm saying now are contained in that the slides that have been shared to all of you. So we have primary source of data collection and the secondary source of data collection. Data collected from primary source are called the primary data, while those collected from secondary source are called secondary data. Data are collected from primary source if they are collected firsthand by the researcher or researchers. I am trying to do a work and I need to collect data. There are various sources from where I can collect data. If I have an already existing data somewhere, like I did mention that Nigerian Nigerian Bureau of Statistics, that they publish bulletins every year, and in those bulletins, it touches almost every aspect of human existence in Nigeria. There we collect data from every of such sectors and then put it in a bulletin and then publish. So in such a situation, if for instance that the information I'm trying to look for is contained in one of their bulletins, and I have access to that bulletin, I collect the data from that bulletin, that the data I have collected is rare. You understand? Is rare. There's not minding the fact that is rare, I did not collect it myself. And as a result, it is not a primary data. Therefore, it is a secondary data because I collected it from an already existing source. I hope it's clear. So, and that is what I have presented, the data collected from secondary source, if they are extracted for use from where they have been collected and kept by another person or stroke group or an agency. So such we know as secondary data. And when we are to use secondary data for our research, it is very important that I put that permission for use of such data must be obtained in this case, unless otherwise stated. How do I mean? There are certain agencies that come up with data sets that are, of course, very restricted, that for you to use their data, you need to seek their permission. And if you go ahead to use it without their permission and the data, and the agency has stated that they have the restricted data, if you maybe use it for your research and then report it, and they happen to get it, they will sue you to court for using their data set without their permission. And of course, it is a very serious academic fraud to use someone's material without permission. Is that clear? So when we are looking for secondary source of data, the first thing that we must establish is that the data is available for use, that I can use it to do whatever thing I want to use it. If it is not available for use, then I must go to that agency to get permission. I hope it's clear. Next. Yeah, responding to me. You can respond. Someone asked a question and said, what if you collect What if you collect the information from patient's folder? What if you collect such information from patient's folder? Number one is that it is secondary data. That is number one. But with respect to permission, you don't have access to patient's folder unless maybe um, unless you are a medical personnel there. And if you are the medical personnel there and you are now collecting such information, of course you know it is unethical. You know that. I hope we are following. And then how do we go about it? You are just a medical personnel, and there are medical personnel in that establishment, okay? And because there are medical personnel in that establishment and there is a hierarchy, so if you will have need of any information that are contained in the patient's folders, you need to go to the hierarchy to get permission. That this is the information I want to collect from patient's folders. If you are permitted to do so, you have obtained permission to do that. But what is not correct is that because you are opportune to be maybe working in a particular establishment and they have the information available to you, and you now begin to collect such information, and then at the end you make use of it. You didn't have permission to do it anywhere. I hope it's clear. You didn't have permission to collect it. So you first of all need to get permission for you to do so. Then if you are not a medical personnel in such a place, you need such information, you go to the hierarchy of that establishment, that this is what you want to do. You want to collect so and so information from the patient's folders. Then if you are permitted to do so, you are free to do that. But if you are not permitted, of course, you don't do that. You have a question? Okay. This question has been overtaken. So don't worry, you can see. Sorry, I asked because you were raising your hand before, but it appears that from my explanation that information has been overtaken. So we can now move on. The following methods exist for collecting primary data. We have different methods of collecting primary data from primary source. Number one is interview method. That is one method of collecting primary data from a primary source. Interview method. The next one is the questionnaire method. And the third is observation method. I hope it's clear. So we are going to look at them one after the other. And the first we are going to look at is the interview method. We all know what an interview is. We all know that at any moment that you are engaging a participant in a structured discussion with the intention of getting the needed information for your research, you are conducting what? An interview. I hope it's clear. And why I say it's a structured discussion is because you cannot just maybe sit down with the participant and you begin to discuss so many things that are not part of your research. Do you understand? Even when your participant is interested in buying off, maybe discussing so many things that are not relevant to your research, it is your responsibility to be doing what? To be guiding the discussion. Even when he buys off, all of us watch the interview sessions on televisions, that even when a participant, when a panelist is discussing certain things that are not in line with maybe what the interviewer has presented or has specified or has scheduled, in such situations, the interviewer has the responsibility of guiding the discussion to the extent that you guide it politely. I hope it's clear. It is equally important that maybe when you are the person that is being interviewed is saying something that is maybe not relevant to the research. If you don't maybe abruptly ask him to stop that, but you try to guide him. There are certain things you say, yes, I love what you have said, you mentioned this and mentioned that. But taking it from that point, you direct the discussion, you ask a different thing, something that is in line with what you are interested in. I hope it's clear. The reason is because human beings, when we are discussing with human beings, we have different kind of people with different what emotional levels. There are especially the topic of discussion. If it's such an emotional one, someone will out of emotion begin to say so many things that are irrelevant to the research you are doing. But it is your responsibility to guide that discussion to be sure that the person is brought back to begin to discuss what you have decided to have. And when we are conducting an interview method of data collection, oftentimes there's what we normally call a schedule that the interviewer should have. What do I mean by schedule? You know already the kind of maybe questions whose responses are going to be part of your data. I hope it's clear. So you have those questions presented in your own piece of paper, which we call a schedule. You have presented that. And as we are discussing, even though the person that's being interviewed may be saying so many things that are irrelevant, but the moment the person hits one of the information that you are looking for, you put it down in the midst of all the discussions, talking and talking and talking. I hope it's clear. You continue on that way until you get all the information that you need from the participant. And once you get all the information you need from the participant, you will now begin to do what? Summarize. Even when the participant has so many other things to say, it is their responsibility to guide the participants to a point of what? A point of stopping. And once the person stops, you thank the person for that. But at that point, you have got all the information you need. I'm sure it's understood. That is interview method. There are different kinds of interview method. We have face-to-face interview and we have telephone interview. I hope it's clear. Then we move to the questionnaire method. For questionnaire method, what is a questionnaire? I said that it involves distributing to the target respondents a list of structured questions which has provision for answers to be supplied with a view to obtaining the responses as the data for research. But sorry, I forgot to say one thing on the interview method. It is equally unethical to engage a participant on a discussion in an interview without first of all letting the participant know that you are conducting an interview. Some persons, because they have seen someone who maybe is vulnerable, and then you begin to ask the person some questions and the person tells you and you are already recording it, at the end of the day, you have your data. It is unethical, it is wrong, it is fraudulent. If you are engaging someone on an interview, the person should know. And that is why you should tell the person that I want to get some information from you that you are being what? Interviewed. But assure the person that the whatever information that you are getting from him or her is for the purpose of your research. And you tell the person the nature of the research you are conducting and what it is going to be used for. Because if you don't tell the person the nature of the research, that person may be careful with the responses is given to you. Who knows where it is going to be reported? Do you understand? But if you assure the person that this is exactly what you are looking for and this is what you are going to use it for, that person will be free to interact with you. And at the end of the day, you get your information and you thank the person. So don't ever engage someone in an interview without getting the person know. It's just like people. Maybe you call someone on phone and you start recording the person's voice. You know it is illegal. It is just that maybe in Nigeria anything goes. But if you record my voice without letting me know, you have violated my rights. And as a result, you can be sued to court. If you want to record someone's voice, well, whatever is in, tell the person, please, you are being recorded. I hope you don't mind. The person tells you, no, I don't mind, or please don't record my voice. And if the person says don't record, please don't record the person's voice. And that is what happens in interview method. So back to the questionnaire method we are discussing. The In questionnaire method, all of us, we know what a questionnaire is. When we have a structured set of questions that we will distribute to our participants, so that as they supply the answers to those questions, it becomes what? The data that we are going to use for our study. Such is a questionnaire. The difference between interview and the questionnaire is that in questionnaire, the person supplies the responses by himself or herself, while in interview method, you are the one, you are recording the what, the responses by yourself as the person is speaking. I hope it's clear. Next. So we are looking at, because most of the researches, especially in social survey, go with the use of questionnaire. We want to look at the quality of the good questionnaire. A good questionnaire possesses certain qualities that makes it what? A good questionnaire. And one of them, we will move at this point, one of them is an introductory note. Every good questionnaire should begin with an introductory note. And what is the introductory note? Where you will tell your participants, solicit for the information, and tell the person what exactly you want to use the information for. And you must not forget to assure the person of the confidentiality of the information. If you don't do all of these things and you jump into asking questions in the questionnaire, people have different views, and someone may begin to think that you want to use this information for something else. And someone will begin to say, maybe you want to know something about me. I hope it's clear. So every good questionnaire begins with an introductory note. Then you will specify exactly what you want to use the information that the person is supplying to you for, so that the person will know, and assure the person that for whatever reason that this information will not be seen anywhere, that is not going to be divulged. And I only want to say, if you have assured someone of confidentiality of information that the person is supplying to you, make sure you mean it. It's not when you have said that so that you get the information and tomorrow the person begins to see something that is related to that, it is equally fraudulent, because you don't use an information that someone has given to you in confidence anyhow. Number two quality is number of questions must be as small as possible. Number of questions in a good questionnaire must be as small as possible. The reason for this is because ethically, you don't pay participants for supplying information in a questionnaire. I understand that sometimes that one may find maybe something to induce the participants, but under normal circumstances, ethically, you don't pay participants for them to supply information. And as a result, you don't give them overwork. So you have to be conscious of the fact that this person that is you are soliciting information from, that this person is busy and this person is not being paid for this, and as a result, you don't need to take too much of the person's time. As a result, every question that is not directly needed for the research, you don't need to begin to beat about the bush asking so many questions when actually you know you are not going to use those information for your research. Number three is that each question should be short and simple. Each question should be short and simple. If it is possible for you to convey the question to the point that your respondents will understand it, even with three words. Do it. I hope it's clear. So that you don't overburden your respondents. You have a question? Take note, just note the question. When we come to the end of the qualities of your questionnaire, you can ask it. Okay? Number 4, quality of a good questionnaire is ambiguous words should be avoided. Ambiguous words should be avoided. There are words that are so ambiguous that when you present it to your respondents, they will make meanings out of those words independently. This person sees the word to mean A, and he begins to respond in the direction of how he has seen the word, and the other person sees the word to mean a different thing, and he begins to supply response in the direction of what he has made out of it. I hope it's clear. So we must avoid ambiguous words. But where, for instance, we must present, no, there is even no need of presenting it, so we have to avoid it entirely. The next quality is questions that pry into people's privacy should be avoided as much as possible. You don't, because you are getting information, even though you have assured the participant of the confidentiality, it doesn't give you a license or liberty to begin to ask some private questions. I hope it's understood. Except where such a private question is the content of the research you are doing. In other words, you cannot successfully complete the research without getting such information. In such a situation, you cannot avoid asking such a question. But as you are asking such a question, it is equally important that because you know you are going to ask some private questions, let it be part of that introductory notes that you specify to the respondent exactly that even when it comes to some private questions, that the person, you are not going to use it for any other thing. And for that to be, how to ensure someone that he is not going to be maybe located by responding to private questions. There are certain things we have to be careful not to do. Maybe assuming you had wanted to include name as in one question. Do you understand? Name of the respondent, put your name. And the person, you are asking the person a private question. That person will be tempted either to avoid that question or to lie. The reason is because there is something, an indicator that can be used to locate the person. I hope it's clear. Or maybe you don't want to ask of the name. You don't want to include name, but you are including something that can be used to trace that person. Maybe you have not presented name, but you are presenting house address, for instance, or phone number. You ask the person to put his phone number, which the person has put, or house address the person has put, and you are asking the person a very private question. So many persons, even when you have assured for the confidentiality, the person will still say, who knows what is in his heart? By asking this kind of question, the person will be tempted to give the wrong information. I'm sure it's understood. So we try to have any private question whatsoever that is not directly important to the research, we must avoid it. And where it is directly important to the research, make sure that you don't ask any traceable question that can be used to trace the participant. I hope it's clear. If I am responding to a questionnaire and I have looked at all the questions and I have seen that once I hand this questionnaire over to you, you will, even you that I have given it to, you can't even maybe point it to me. Then I will be free to give you any information that you are asking. I'm sure it's understood. Next is that leading questions should be avoided. Leading questions should be avoided. What do you mean by leading questions? Suggestive questions. Questions that are suggesting answers. We should avoid it. How do I mean? You are asking someone maybe a question, an opinion, and you ask the person, don't you think that this idea is good? Because the person doesn't exactly know, even though you have assured the confidentiality, the other person may not maybe go with that confidential assurance 100%. And you have said, don't you think? And the person will say, yeah, yeah, I think it is so. I hope it's clear. And in such a situation, the person's mind, he has not presented it to you. Be as objective as possible so that your participants will give their objective responses. Otherwise, they will tend to agree with you. And as they agree with you, it is going to hamper the outcome of the research. Next is that offensive or highly emotional questions should be avoided as much as possible. Offensive or highly emotional questions should be avoided as much as possible. We all know what we mean by that. In your questionnaire, you are asking offensive questions, something that will make your participant to get offended. How do you think that he will even continue to give to answer? He has picked with your question. So they can just pick the questionnaire, fold it and put in a trash can. And if the person doesn't mind, if there are some kind of people, they will say nonsense. And that ends it. I hope you understand. That is on the side of offensive questions. On the side of highly emotional questions, there is a question that you ask someone, and the person reads the question, and before you know it, and begins to have, the person may even begin to cry. And in the course of crying, the person drops the questionnaire, and that person may not go back to it again. Even when he goes back to it, as he picks it again, he sees that question, and something cloud will begin to move around the person's eyes, and before you know it, he closes it again. Even if the person will eventually complete the questionnaire, he may not complete it on time. And it takes the grace of God even for the person to go back to it. The person may say, I don't want anything that will remind me of this thing. I hope you understand. And in order not for the person to be reminded of that thing, that person will not go back to that questionnaire and you will never have it. So that is why we must avoid it. The next is that the questionnaire should guide the respondents into questions with possible open-ended answers. You know, there are some questions that have open-ended answers in a questionnaire. When we are drafting a questionnaire, we normally structure the answers in such a way. Let's have one house, please. One house. When we are asking questions in the questionnaire, we try to structure the answers in such a way that as you read, your answers must be one of the what? Structured responses. I hope it's clear. But at the same time, there are certain questions that we cannot structure their responses. And when we are asking such a question, we try to guide the respondents on exactly the type of answers that they should do what, that they should supply. So when we have done all of this, if we follow all of this, we will be able to come up with a questionnaire that will be able to give us exactly what we need for our research. Now at this point, I have not forgotten. Ask your question.
For every public that when are we supposed to seek solution or not when we say that? Because if we want to say education, we are in the literature, you want to refer to that aspect and able to start writing your own research. You say it is a judgment on the rights, maybe I'm using it.
Okay. Oftentimes, when we see a published work, are we together? If a work has been published and the publisher did not specify that you must get permission for the reuse of the data, what it implies is that it can be reused. Did you get me? Written data. What do you mean by written data? Maybe a qualitative data. Is that what you mean? Yes. Mm-hmm. 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 Can you give an example of a written data? Just a simple example. Mm-hmm. Different. Okay.
Someone published again and wrote kneeling.
Mm-hmm.
And you come and saw a systematic disease where somebody brought, you do so many of them, and you try to reach a consensus.
Mm-hmm.
And now you now went down the tunnel, like you now wrote creative companies,
Mm-hmm.
you are not permitted to use adopt, or some people will say use for free,
Yeah.
but there is no table in that obligation. There is no fee. It's just a written data. So
Okay.
can you use that data, paraphrase it and put it in your work, maybe in the paper or in your research?
Okay. I think I've got the question that she's asking. Whether it is a table, whether it is a figure, whether it is not a figure, but it has been published and there is a creative common where it is said that maybe no part of this work should be reused without the written permission of the publisher. Are you getting me? What that means is that if it is a table, for instance, they are not saying that you should not borrow their idea and cite them. What they are saying is, if they have a table, don't copy the table and use. If they have a figure, they are not saying that you should not report their figure. That XYZ conducted this work and they came up with this figure. That is not what they are saying, because every work can be cited. But what they are saying is, probably they have a table. Don't copy their table and use without their permission. I hope it's clear. So, but if there is any, maybe something that is written in the work, they are not saying you should not cite them. They are not saying you should not borrow their idea. I hope it's clear. So if they have finished and they came up with a finding, maybe they will have seen that this is this and this, or that a percentage of people with this particular betting position is maybe 70. Percentage of these people is that. You have the right to say that they have done this work and they came up with these figures, provided you cite them. I'm sure, I hope it's understood. There was a hand, yes. Okay. Yeah. It's all right. Mm-hmm. Yes. Mhm. Okay. Thank you. What I have said, can we be quiet, please? What I have said about emotional questions, I said a highly emotional questions. There are questions that we know that, of course, call for what? Emotions. While there are some that somebody may be emotional about, but ordinarily it is not regarded as what? Highly emotional question. As a result, what I have said is avoid the highly emotional ones. And even when you cannot avoid it because of the nature of your research, you try the much you can. First of all, present maybe in a light that somebody will understand. And present it, I have said it before, present it to the person that why you are asking this question is so that you'll be able to do this or that. I'm sure it's understood. Then lastly,
Thank you so much, sir. I noticed that there was a time you want to mention respondents, you mentioned the now go participants. Please, we have been interusing subjects, participants, and respondents. In what area do we use all these words? Because we'll be using them maybe normally or abnormally. Thank you, sir.
okay, I will throw the question back to you. How have you been using them?
Okay, sir. I know I've been using maybe if it's a questionnaire, I will use participants.
Okay,
Eh, Then if it's an interview, I'll use respondents.
okay.
Then for subjects, we still use them as subjects, knowing that maybe it's somehow derogatory, maybe you're subjecting somebody to something. But I want to be clear. That's why I put out the question. Thank you,
Okay,
sir.
thank you. Whether it is called respondents or participants, they are saying the same thing. Respondents because they are going to respond to your questions, whether it is interview or whether it is questionnaire. Participants because they are the people that are participating in your study. Then subjects because they are the individuals that you are getting questions from. In other words, the responses are coming from them. What you are working with is what you have obtained from them. There are no other, you don't have any other person that you are getting information from. Is that clear? Now, finally, we look at observation method. This method is used in experiment-based research. What I mean by experiment-based research is mostly when we are doing laboratory experiment research, we do observation method. I hope it's understood. That is very clear. The only way to get information from a laboratory-based research is by what? Observation. You may decide, maybe there is something that will give you an indicator that this is the time to collect your information. Whatever way, if you have put something, I remember those days in secondary school, if you are doing titration, what are you looking for? A color change. Once the color changes, it is time for you to do what? For you to get your value. I hope it's clear. And that value you are getting it by observation. What you have observed the value to be, you put it down. That's all we can say about observation method. So let's move next. Yes, take just put down the question. Okay? Put it down somewhere. Later on, I will call for it. So, the next we'll begin to discuss now. When we have used either interview method, we have used questionnaire method, or we have used observation method, there is always an end product of the use of those methods. And what is the end product? Is data. Data for the research. Even if we use the secondary source, what is the end product of the secondary source? Data. So at this point, when we have used all those methods, we assume that we have now collected the data for the research. So at this point, we have come to how do we handle the data so that we will be able to have what we need to have, which we are going to discuss. And that is data analysis and interpretation. And I will say again here, when data has been collected and presented, there is little or no information that may be elicited from such data unless they are subjected to statistical means of data handling, otherwise information. When you have gone to the field or you've gone to the lab and you collect your data, as you look at the data, there may be nothing that you can report about the data. Is it true? You can only make a valid report when you have subjected the data to what? To analysis. I hope it's clear. I actually want to say that when we have collected such data, it is still a raw data. Is that clear? And because it is a raw data, we will need to do what? Process it in the form that we can now subject it to analysis. Different processes can be used. And the process that how we are processing data for analysis depends on the type of analysis we want to use. I'm sure it's understood. The process that a particular data will undergo, if it is going to be subjected to maybe descriptive statistics, may not be the same process, the same set of data will undergo if it is going to be subjected to an inferential statistics. And even when it's going to be subjected to inferential statistics, the method of analysis that is going to be used for such a data set determines the level of processing that it will go through. I'm sure it's understood. The essence of that is to make sure that the data is what? Ready for analysis. Okay. Again, part of the processes may be, I want to start with this elementary part, maybe where you need information on maybe state of origin of your participants. And when you have that state of origin, you will have different states presented in the data. Are we together? I may decide that in processing this data, I need to group these states of origin according to geopolitical zone. So that when I will be reporting, I will report based on geopolitical zone. Is that clear? In such a situation, part of the processing will be, once I will have 6 geopolitical zones, for instance, and I will now decide what label I will give to each one. I call it label now because yesterday we discussed labeling this kind of data, which we call nominal data. I will decide, okay, once I see North Central, I will call it 1, Northeast 2, Northwest 3, Southwest 4, south-south 5, southeast 6. These numbers 1 to 6 are known to me alone. Another person may choose another labeling. I hope it's clear. It's going to be part of the processing. I'm sure it's understood. Again, I may want to carry out a research that involves school children. And the age is important. Age of these children is important to the research. But because of I have asked them their age values, and we obtain the so many age values, but I have looked at it that I will need to divide these all the age values into two, so that I will have younger children and what? Older children. I will define who a younger child is. Maybe a child that is less than or not more than 7 years. In my own research, I will label such a child what? A younger child. But any child that is more than 7 years, I will label the child what? An older child. For instance, I hope it's clear. So part of the processing will now be I will go through their ages. I may say younger children 1, older children 2. So in the age, what will be seen in my data will be what? 122, 111, 222, and so on. I hope it's clear. It is part of the processing. All of them put together. By the time we have done all of this, we have processed the data. And the data is now ready for what? For analysis. So I said again that there are different analytical tools in statistics. There are different analytical tools in statistics. The first we are going to be discussing is the descriptives. The descriptives. Descriptive statistics. That's what I mean by the descriptives. By the time I have a set of data, and my interest is to find maybe the mean, compute the mean, compute the standard deviation, compute and so on and so forth, percentages. By the time I'm doing all of this, or maybe frequencies, if I am doing all of this, I am at the point of what? Descriptives. I'm sure it's understood. So that is the descriptive aspect. Maybe I want to report. I want to take percentages, percentage of the responses that belong to this, percentage that belong to that, and so on. All of them are what? Descriptives. The next part is that we can as well begin to have different tests of hypothesis, which of course is influential. We may have tests of hypothesis involving proportions. And then when we have tests of hypothesis involving proportions, we can as well present the tests and interpret the tests. We can as well have tests of hypothesis involving means. When we have tests involving means, we can still do what? Present it and interpret it. And well, some cases we may have tests of hypothesis involving the standard deviation. And when we have such, we can present it and interpret it. Apart from that, depending on the objective of the research, we may begin to be interested in relationships between variables. And when we are interested in relationship between variables, we'll be discussing maybe how to handle relationships, which will lead to things that we know as maybe correlations and the regressions. So if that is the objective of the research, the analysis can go in that direction. At the same time, one may be interested in the use of graphs and plots. Maybe I have presented all of this, but I need to do what? To put graphical presentations of them. I need to plot the responses. And with that, one will be able to probably look at the plots, interpret the plots, and use it to report the findings. I hope it's clear. All that we do majority of all that we do in our researches, they revolve around all that we have said. So, I have just discussed all of them completely, but I will now need to, apart from the descriptives which I have given completely, I will come to what we know as tests involving proportions. Tests involving proportions, and I have said here that there are tests involving one single proportion, the second is two proportions, the third is several proportions. Then, when we are coming to several proportions, we may have one way and then we may have two ways. When we have tests involving proportions, whether it is one way, single test of proportions or test for difference of two proportions, both of them can be handled with what we know as t-test. With what we know as t-test, we can handle tests of hypothesis involving one proportion or difference of two proportions. So when we are interested in that, it can be handled by what we know as t-test. But when we come to tests of hypothesis involving several proportions, we use what we know as chi-square. We use what we know as it is a chi-square test. Whenever we are discussing tests of hypothesis involving several proportions, then the statistical tool to be used is what we know as a chi-square test. Is that clear? Now, in chi-square test, we have one-way chi-square test, and we have two-way chi-square test, or even multi-way chi-square test. The simplest is the one-way chi-square test. I will give a simple example of a test that can be handled with one-way chi-square test. It is a test of goodness of fit. Another word name for it is goodness of fit. Test of goodness of fit, which we call chi-square test of goodness of fit. Let's assume, I want to make a little illustration there. Let's assume that I'm interested in studying the distribution of patients that are suffering from a particular ailment, their distribution in terms of their blood group. Okay? We want to find out, are there some blood groups that are more prone to this particular ailment than others? I hope we are following. So let us assume that we are studying this particular research using four blood groups. Blood group A, AB, O, and which other one? And B. Good. I have gone to the hospital and I have, in my sample, let's assume that I have 100 participants for the study, and I have obtained their blood groups of those 100 participants. Then I will now be checking their proportions. What proportion am I interested in? Proportion of these 100 participants that have blood group A, proportion that have blood group B, proportion that have blood group AB, and proportion that have blood group O. Is that clear? When I have obtained these proportions, I will now my interest will now be, is it possible that these proportions are the same? Are they the same? I know very well that they are not going to be exactly the same. Is it not so? Because I obtained the data from a sample. So they are not going to be exactly the same. It is possible that blood group A has a proportion of 0.2. Blood group B has a proportion of 0.05. Blood group AB has proportion of 0.6. Blood group O has proportion of 0.25. When I add up all of them, it is going to be equal to what? 1. I hope it's clear. Now, my question is, even though they are not the same, but I want to test to see if the differences in them came as a result of chance, or if it really means that in that population that the proportions are not the same. I hope it's clear. It is when we subject it to test. So this is a chi-square test of what? Goodness of fit. If they are going to be the same, I will be saying that they have equal proportion. And 1 divided by 4 is going to be what? 0.25. Is it not so? So I will be hypothesizing that they all have the same proportion. That blood group A is equal to 0.5, that of B is 0.5, that of AB is 0.25, and that of AB is 0.25, and that of O is 0.25, meaning that they all what? Have the same proportion. So when I have stated this, I will state an alternative hypothesis that they are not all equal to 0.25, meaning that some are more than what? 0.25. And for me now, I will subject it to test. Because I have obtained the pattern I am testing is that they are all equal. So I will now subject the result of the data which I have to this to see if they are all equal. I hope it's clear. By the time I end the test, I will come up with either one or two results. What is number one? Maybe that there is a significant difference in their proportions. And if there is a significant difference in their proportions, I will now conclude that the proportion of the patients that are suffering from this ailment that is not the same with respect to their what? Their blood group. I hope it's clear. Because this is small, because we have 4 blood groups. What we have concluded at this point is that they are not what? Equal. That is one output. The other result may be that even though they are not the same, but there is no significant difference in their proportions. At that point, I will conclude what? Even though we have seen that the observed data that we have shows what? Differences in the proportions. But these differences are not significant enough, which means that actually that there are what? There is no difference in the proportions. I hope it's clear. So that is what we do here in one way chi-square test of goodness of fit. There is yet another way we can handle this. Maybe WHO has stated that in this same example that we have given, okay, WHO has stated that those that have blood group AB, that they are more prone to this particular sickness than others. Is that clear? When I have this now becomes a confirmatory research. I want to find out if the people that are suffering from this disease in this particular locality, do they conform to this WHO standard? I'm sure it's understood. In this case, I will be still present it in that way. So I will now be checking if there are actually those that have blood group AB, if they are actually higher than others. or not. At the end, I will still come up with one of two results, that they are actually higher or that they are not higher. I'm sure it's understood. And in whichever way, this is what you know as chi-square test of goodness of fit. But there is another type of chi-square test, which is not chi-square test of goodness of fit. This one is called chi-square test of independence. And what is chi-square test of independence? Chi-square test of independence is when maybe we have two variables of interest. Maybe let one of them be gender. Okay? Gender is one variable of interest. And maybe the other variable of interest will be, let's assume, still is that no. Mm-mm. Don't don't put anyone in my mouth. Allow me to think out one. The reason is because all that they have presented, there are variables that are not, that when they are combined may not make a complete research. So we need to include the study variable. So I have said gender. Now gender and the other example I have given, I want to borrow something again on blood group. Is that clear? So my interest now is I want to find if blood group of people, if it's dependent on what? On gender. Do you understand? So that one will be able to say that maybe gender has two values, males and females. So that one will be able to say that maybe females are more prone to this type of blood group than males. So I have this variable, which here is a grouping variable, and then I will have the study variable, which is the what? The blood group. So when I am now checking, is there any dependence or independence in the outcome of the blood groups with respect to the gender? What I will be doing is I'm carrying out a chi-square test of what? Independence. And this can as well be done. Maybe I want to still present another particular example. Someone is carrying out a research and then the person wants to find out, maybe on school children, you want to find out if maybe, what do we use now? If the age or I'm trying to, okay, we have school children and the one is carrying out a research and the person wants to find out. We know there are differences in the there are differences in their level of assimilation. And the one wants to, if it is possible that the person has defined those levels of assimilation and has linked it to a particular maybe health challenge that children may be having. And then one is trying to find out if at what age that this maybe level of assimilation is higher than the other. In such a situation, one can break those children into maybe 4 different age groups. I hope it's clear. And then when we try to look at the 4 different age groups, and they have different levels of assimilation, and one is trying to check, does age depend, or their level of assimilation, does it depend on their what? Age. For one to do this, the person carries out what? Chi-square test of what? Independence. I'm sure it's understood. So these are the two types of chi-square tests that can be done. The next is a test involving maybe means. There are different tests involving means. The first one is test involving a single mean. The next one is test involving difference of two means. When we are discussing tests involving a single mean or test of difference of two means, the normal t-test that we do can handle any of two of them. Is that clear? But if we are looking at the test involving several means, then t-test doesn't have the capacity to be used to handle several means. At this point, we go to another statistical tool that is known as ANOVA. So ANOVA is a statistical tool that is used to do what? Carry out tests of hypothesis involving what? Several means. And when we have said that, there is equally another, maybe, is it younger now? Yes, younger sister to ANOVA. And that is what? ANCOVA. ANCOVA is actually ANOVA. They follow the same principle. But the difference between them is the variable that we are interested in checking, if it differs as we move, if the means differ as we move from one to another. If there is another variable that we have obtained which is related to that study variable, and we are interested in bringing it into our analysis, then we now say that that other variable that we are bringing in, because it is closely related to the variable of the study, that it co-varies with the variable of the study. As a result, we now call this ANOVA as what? ANCOVA, which is analysis of covariance, while ANOVA is analysis of variance. ANCOVA is actually ANOVA, but in the presence of another variable that co-varies with the study variable. I will give an example. And the example I will give, which we normally, for most of the times, encounter in survey, is maybe there is a particular study variable that we are interested in, but we know that, especially there is what a social scientists do that they call intervention work. I'm sure, I don't know if you know what I mean. Intervention research. Intervention research is maybe when I have noted some persons that have a particular impairment, okay? And I am interested in seeing if an exercise improves their performance, improves that impairment. I don't know if you understand what I'm trying to say. We have noted that these individuals have this particular impairment, but somebody has come up with something that helps those individuals that have that particular impairment. And we are trying to ascertain the level of help that particular thing, when it is introduced to them, we want to ascertain what level of help does it actually give to them. Do we understand that? For us to do that, maybe we want to test their improvement with a particular test. Okay? So what do? We will first of all bring that same test that we want to use to test their impairment. As we have recruited our participants, we will give them that test at the very beginning. When we have given them that test at the very beginning, we will take notes of their performances at that beginning. When we have done that, we will now bring about that particular help, which is the intervention. We will subject them to that particular thing that has been introduced to help them in that situation. We will subject them equally to that particular strategy of improvement. When we have subjected them to that, to a certain level, we will now do what? We will bring the same test again and give to them. I'm sure it's understood. When we have given them the same test again, we now have what? Test before and then test after, which is pre-test and what? Post-test. At the same time, maybe someone is a health worker and he wants to maybe train women in a particular locality, or maybe the safety principles or precautions for a particular thing. And we gather them. At the very first time we have gathered them, what do? We test them on the knowledge of those safety principles. Do you understand? After that, the training will now begin. We will start training them. At the end of the training, we bring the same test and give to them again. Then we will now be, for each participant, there is pre-test results and there is what? Post-test results. Because we are getting these two results from the same individual, one will be sure that there is a correlation between the results. Those that performed better before, if they continue to perform better, the question will now be, what is the significance of this training? The significance of the training is going to be obtained by the differences between the pre-test results and the post-test results. I'm sure it's understood. And how this is normally done for it to be a complete and comprehensive research is that when we have when we have gathered the participants and we have given them the pre-test, we will not use all of them again. We will divide the participants into two to have a control group and what? The test group. So when we have it, that control group will not be exposed to that training. Or if it is in the case of improvement of impairment, that control group will not be exposed to that what? Improvement strategy. I hope it's understood. But for those that have maybe been subjected to the training or the improvement strategy, at the end, we will do what? Gather all of them again and give them the same test again. The expectation, if that training is significant, if it has helped them, or if the impairment improves, the expectation is that those those in the control group will continue to score something close to their former scores, while those in the experimental group or the test group, it is expected that they will improve more than those that were not given before. I hope it's understood. So in this case, one will now be seeing that the pre-test result is a variable which is related to the what? The post-test results. So if one wants to carry out, maybe to subject these results to analysis using ANOVA, the use of ANOVA there will be to use only the post-test results. That brings about what? ANOVA. But if you use only the post-test results, you will not be able to give the accurate results, because the effect that you are going to be reporting may not be the effect of that intervention. I'm sure it's understood alone. It may be the effect of the intervention plus some other factors. So for us to be sure that we are trying to find the effect of the intervention, we must marry the post-test result with the what? With the pre-test results. I'm sure it's understood. When that is done, this type of analysis, ANOVA will now become what? Analysis of covariance. I'm sure it's understood. There is still yet another way that this type of test can be done using only ANOVA. And how is it? The only way it can be done using only ANOVA is that the person, the experimenter, decides, I don't want to bring in anything ANOVA in this work. And because, sorry, I don't want to bring in anything ANOVA in this work. I want to make do with only what? ANOVA. The only way to do that and to make do with only ANOVA is to, first of all, before subjecting it to analysis, you will take the differences. The data that we are now going to be subjecting to analysis will be what? Differences between post-test minus pre-test for all of them. I hope it's clear. In such a situation, we have only one variable now. But this variable now is no more post-test result, it's no more pre-test result, but what? The differences between the post-test and the pre-test. So when I have it, I can subject it to just what? ANOVA. And it will, whatever result I'm getting from there is exactly going to be the same the result I'm going to get if I had conducted what? ANOVA. I'm sure it's understood. Let me run through. Note it down. Most of the times in research, we don't normally get ourselves involved in carrying out tests about variance or standard deviation. We don't normally get ourselves involved in that, and because of that, I will not say much about that. And as a result, that is all about that. I can now take, there were two persons I asked to wait, so I can take their questions, beginning from you. Okay.
In a situation whereby you observe, if you finish talking in office, hey, okay, in a situation whereby you are observing a group of health workers to know whether their reports on following a particular guideline to carry out a procedure is in line with what they reported in a questionnaire.
Repeat that again.
For instance, if you are using two methods to collect data, questionnaire and observation, in a situation whereby maybe you want to find out whether what they said is actually practiced, and you passed out a questionnaire, and you have already decided to observe them. Sir, is it right to observe them while they maybe while you are waiting somewhere, maybe around, to find out their practices? Is it like infringing on their rights? And if it is so, if you tell them that you're observing them, won't it affect their behavior? Would they not try to do the right thing when they already know that?
Close the windows.
Close the windows.
Or you roll up the blind.
Can you roll it up? Okay, can you complete the question?
Okay, sir. The summary of what I'm trying to say
not informing them influence the results, then if I am to carry it out without informing them, is it right professionally?
Okay. Thank you for the question. Some persons have tried to answer it for me. They said it is not right. And then I want to say, I hope we are all listening. When we are talking of observation method of data collection, I remember very clearly that I never said that for you to observe, that you must get permission to observe. I did not say anything that has to do with getting permission during observation. The only time I talked about permission is when you are conducting an interview and when you are giving questionnaire, you get permission, or when you are taking information from a recorded document, you get permission for such. But if it is observation, the only thing that you may need in observation method is to get permission for someone to be a participant in a study. Okay? If you have secured a permission for someone to be a participant in a study, that is enough. The time, whatever thing that you are doing to get information by observation, that does not require permission. Did you get what I mean? Because the reason is because you can't be observing someone and you are telling the person, watch you, I am observing you. If you tell someone that you are observing, the person will adjust. And the information that you are getting, you may not be able to get it. What is important there is if you are having a particular set of participants you want to use, they should know that they should give a consent that they want to be part of the study you are doing. But if it is a matter of observation, then you don't need to inform them that you're observing them. Is that clear? Now, let me finish with that. You have a question?
Yes. So thank you for the opportunity. Like for somebody carrying out an interventional study and your population, you're making use of secondary school students, for instance, they are 700 in a number, the entire population, you have to be different from them. You got your sample around 350, which is what's supposed to be. So you now start with pre-test, and that pre-test, you tested everybody. And got their response. When you now want to do post-test, are you going to follow up those people that you tested initially, or can you test every other person and it will supply the post-test?
Thank you. They have answered for me too. They told you no. Let us be very specific. When you begin to do that, it is no more research, because the essence of pre-test and post-test is to remove an effect. And what is that effect? To remove the effect of prior knowledge before the intervention, or to remove the effect of the level at which they were before the intervention. So when you have not removed it, when you try to remove it, the essence of the post-test and pre-test is just to remove the effect of the original level where they were. So when you have selected a certain set of individuals and you carried out a pre-test, now during the post-test, You now see suddenly you saw another set of people. Then the first question is, did you actually define your sample from the beginning? And you see that the obvious answer is what? No. Anybody that comes is welcome. But if you have defined it originally, you will not go outside the people that you have tested before. Now, I only want to say at this point, there is something that is possible that may happen. Maybe you have tested 350 at the very beginning. That is your sample as with pre-test. By the time you complete the intervention, maybe you have now completed the intervention with 300 people. Are you with me? It is now shorting what? 50. What are you going to do? Report that you started the work with what? 350. But at the end, only 300 completed the experiment. I'm still coming. Let me finish. So, because of the fact that there are 300 that completed, you will now go back to the pre-test results that have 350. You will begin to match them. These post-test results against this particular post-test result for a particular participant. Post-test against pre-test, post-test against pre-test. At the end of the day, there will be 50 of them that will not have the post-test or the post-test results. Is it not so? You will report that this is what, at the same time, you will not be expected or requested to now go gather some people elsewhere, give them pre-test, then start the intervention again. When you finish, give them post-test so that you will go to the original participants you have. You remove those that don't have the post-test results and then replace them with these new ones. That is not what you're expected to do. What are you expected to do? Go and remove those 50 that don't have the post-test results. Conduct your analysis with the remaining 300 and then report it. I'm sure it's clear. There is always a case of non-response, and it is a problem of its own in research, and we will not delve into that. But what becomes an error is that you go and begin to test anybody to begin to match them so that you will maintain the 350 which you had given. Do you understand? Okay.
All right. Good afternoon, sir. Thank you very much for your brilliant teaching. I have just this one question to ask. You made mention of regression analysis. You made mention of regression analysis, which is the comparison or the comparison of two variables. And you also made mention of the chi-square independent test. So, which is also the measurement of two variables, which is the grouping and the study variable. So I wish to know if these two tests are the same. Then I also wish to know the significance of p value in alternative and null hypothesis. Thank you.
You're welcome. She asked the question based on what I mentioned, and she is not wrong. She is right. I tried to explain chi-square test, but I have not explained regression. It is still possible that I may not explain that. Hold on now, let me finish. But I think the issue of comparing two of them to understand the difference between them should come if I have explained the regression, then it is possible that by the explanation, I will be able to understand, oh, this is the difference between them, and there will be no need of the question. It is possible that I may still not be able to distinguish between them, and then the question will come. So what am I trying to say? Why don't we wait? If we get to that point and they explain that, or if we are not able to meet it, then we can now ask what is the difference between them. So for now, know the chi-square test which I have tried to explain. I mentioned the regression in person. I have not said anything about regression. You were even the one that told me all the things that you told me about the regression. That is good. So, next.
Okay, thank you.
I think there's no need for all of this.
Okay.
Let's move. Uh, General steps. Let's move to general steps. So, with all that I have said, I have mentioned the several tests of hypothesis. I mentioned tests of hypothesis involving one proportion, tests of hypothesis involving difference of two proportions, tests of hypothesis involving several proportions. I mentioned the three of them. I went further to mention tests of hypothesis involving a single mean, tests of hypothesis involving difference of two means, and I went further to mention tests of hypothesis involving several means. When it is just for the study variable, and when there is a variable that is correlated with the study variable, which gives rise to ANOVA and ANCOVA. I have mentioned all of this. Is that clear? Having mentioned them, when we now want to conduct the test itself, the proper tests, we want to look at the steps that we go through in conducting these tests. All of them follow the same steps. They all follow the same principle as we test the hypothesis about them. Is that clear? So, the number one step in every test of hypothesis that we have mentioned is to state the null hypothesis. The null hypothesis. And what is the null hypothesis? The null hypothesis is usually stated to show non-significant results. It is always stated with nullity. There is no difference. There is no significant difference. This and that, they have the same effects, that they are not independent, they are independent. All of these things are used to present what? Null hypothesis. The very striking statement about null hypothesis, amongst all that I have said, is that null hypothesis always is stated to show what? No significance. When we have stated the null hypothesis, the alternative, the next, which is in step 2, is to state the alternative hypothesis. The alternative hypothesis is always what? A negation of the what? The null hypothesis. Now, I want to say at this point, what becomes the null hypothesis of a research or the alternative hypothesis of a research depends on the objective of the research. For this particular research, it may be the null hypothesis that is of interest to the researcher. To another research, it may be the alternative hypothesis that is of interest to the researcher. Do you understand what I've said? How do we mean? If I am looking for maybe the example I gave before, WHO has come up with a standard proportions for people that are suffering from a particular ailment in terms of their blood group. And WHO says that they are in the ratio or the proportion of blood group A 0.2, blood group B 0.1 or 0.1, blood group AB 0.5, and blood group O 0.2. This may be a standard that WHO has come up with. Is that clear? And I am trying to, the interest of my research is to find out if these people suffering from this particular ailment in this particular region, do they conform to WHO standard? Are you getting me? In this case, when will they conform to the WHO standard? If their proportion differs in line with what WHO has stated. Is it not so? That if their proportions are the same, then they don't do what? Conform. The null hypothesis for this research will be what? Against the WHO standard. Do you understand? As a result, the null hypothesis will be against what I'm finding out. I want to see if they conform to WHO standard. And WHO standard is that they are not equal. Is that clear? In the same way, even at that point, my null hypothesis remains the same. And what is my null hypothesis? They have equal proportion. While the alternative is what? They are not equal. So in this case, it is the alternative that supports what? The claim. Do you understand? The claim I'm trying to find out, I'm claiming that, I will claim that these people in this region, their proportions are not the same. In other words, they conform to the WHO standard. So that is my claim. So as I go into the test of hypothesis, it is the null hypothesis that is against my claim. Do you understand? While the alternative is in support of my claim. Are we together? There may be another research where I am looking at somebody has come up with a claim. And what is the claim? That this particular ailment has nothing to do with gender. Are we together? As a result, in my null hypothesis is that what? That gender is not significant. Do you understand? While the alternative is what? That gender is what? Significant. As a result, in this case now, it is the null hypothesis that is what? Supporting the claim, which is the subject of the purpose of my research. While the alternative hypothesis is against the what? The claim. Do you understand that? So what becomes the null hypothesis or the alternative hypothesis has nothing to do with the objective of the research. What is important is that null hypothesis must always be what? Non-significant. Is that clear? In some researches, the null hypothesis supports the claim of the research, while in some other ways, it is the alternative that supports the claim of the research. That is the point I'm making. But when we state the null hypothesis and the alternative hypothesis, the next step is to determine the level of significance. Is to determine the level of significance for the study. We determine the level of significance for the study. What is level of significance of a study? For us, we normally define level of significance if you may leave it or you listen to it, but we call it a maximum probability of committing the error of type 1. We will still come to that because there are errors that are inherent in terms of hypothesis. So we want to look at what is the maximum allowable probability of committing the error of type 1. Some other times we may understand it at this point that level of significance is the what? The level of precision that we are interested in. So some other, we may just look at it as precision level of a research. Is that taken? It is a kind of maximum error that we can allow in that word, in that text. So we will state it. It is not any other person that will give it to me, but it is the researcher that will do what? That will state the level of significance. For a normal classroom work, we normally use a generic level of significance, which is what? 5%. And then what is 5% in decimal is what? 0.05. So we say that the level of significance is 0.05 or 5%. That is generic level of significance for a classroom work. Assuming we are here, we are doing tests of hypothesis and with examples, we can just say, let's take level of significance of what? 0.05. Is that clear? But then, when we are doing research, level of significance does not begin and end with 0.05. It is for me to decide what margin of precision do I want to state for my research. And it is always that the higher the margin of precision, which is the higher the level of significance, the higher the error that may be introduced in the findings, and the lower the margin of precision, the what? The lower the error. Is that clear? If I say, for instance, that my level of significance is 0.05, what does it imply? It implies that I can accommodate 5% of error. You understand? Another person says that his level of significance is 0.01, which means he wants to conduct his research by accommodating only but what? 1% of the error. Do you understand that? So it is the researcher that decides the level of significance to be what? To be introduced in the research. And whenever we are deciding this, it must be with in agreement with our supervisors, so that we don't decide on our own. Is that clear? It is equally important that I state here that sometimes most statistical software that may be used to conduct these tests of hypothesis, they will have one house. I want to repeat again, most statistical software that can be used to conduct these tests, they don't use level of significance as a way to carry out the test. Rather, they use another form of level of significance, which we know as p-value. There is another aspect of test that makes use of p-value. And what is actually p-value? P-value in full means the probability value. And what does it mean? It means observed level of significance. And it is now, when I have obtained an observed level of significance, I can now begin to compare it with a stated level of significance, or I can begin to report based on that observed level of significance. How do I mean? If I am carrying out a test and I obtain a p-value of 0.012, 0.012, do you understand? This is 0.012. I will now begin to compare it with possible levels of significance. First, I compare it with 0.1, which is 1%. I'll find out that 0.012 is more than 0.1. sorry, 0.01. Is it not so? Therefore, that particular test is not significant at 1% level of significance. Are you following? But I can go further to compare it with 5%, which is 0.05. I will find out that it is what? Significant at what? 5% level of significance. I just concluded the test without specifying a level of significance. And the test generates what? A observed probability of observed level of significance. It is now for me to begin to compare that observed level of significance with what? With a stated level of significance. So that is why I may begin to say that if it is maybe I got a p-value of 0.0012, which is still less than 1% level of significance, less than 5% level of significance, I will conclude that the test is significant both at 1% level of significance and 5% level of significance. Do you understand? So most software, they come in that way by, instead of reporting what we know as the um, the value of the statistic, they will report the p-value, so that they have now left us open to do what? To push the level of significance at which what we have tested will be significant, and the level of significance at which it will not be what? Significant. So, in that step 2, which we are explaining, we have said is to determine the level of significance, which I have told us is the maximum probability of committing type 1 error. There are 2 types of errors that we commit in terms of hypothesis. They are called error of type 1 and error of type 2. Error of type 1 is when we reject a null hypothesis when it is not supposed to be rejected. That is error of type 1. We go ahead to reject a null hypothesis when that null hypothesis is not supposed to be rejected. Okay? By so, we have committed an error, and that error is what? Error of type 1. Then the other type of error is error of type 2. When we fail to reject a null hypothesis, when it is what? Supposed to be rejected. We did not reject it, even though it is supposed to be rejected. That is another error. It is called error of what? Type 2. So we have type 1 error and type 2 error. It is equally important that I state, well, maybe this may concern statisticians, that oftentimes we will say we accept the null hypothesis. Okay? It's a general thing that you can even see in statistics textbooks. But ordinarily, null hypothesis is not supposed to be accepted in a research. It is either you reject it or you don't reject it. Don't reject, you are not rejecting it does not mean that you have accepted it. What does it mean? It means that you were not able to find a sufficient evidence to reject it. Because every test of hypothesis is wired towards what? Rejection of the null hypothesis. But when you have tried everything to reject the null hypothesis and you could not reject it, end at that point. That you have not been able to reject it does not mean that you should accept it. Do you understand? I don't know if did I confuse anybody? Yes, opposite of reject is accept. But in terms of hypothesis, we are looking at rejection and not rejection of the null hypothesis. That I failed to reject a null hypothesis does not make it to be correct. The only thing is that from the available data I have, I don't have any evidence to reject it. It is possible that if I had gone to the field again to collect another data, maybe I will see a sufficient reason to reject it. Is it not so? So that I have not rejected it does not imply I should accept it. I hope it's understood. This is the language in terms of hypothesis, the very correct language. We don't accept a null hypothesis. Rather, we say that we do not reject this null hypothesis, meaning that there is no evidence to reject it. And if you don't reject it, well, it may imply so many things may come up. It may imply seek, go further to look for further data. It may imply leave it at this point since you could not find any evidence to reject it. Assume it to be correct. Do you understand? But if we are assuming it to be correct, it doesn't make it to be correct. I don't know if you understand what I mean. You are assuming it to be correct based on the information you have. If probably you have got an additional information, you may see reasons why you should reject it. So the step 3 in test of hypothesis is to conduct the test using a given test statistic to obtain the p-value. Conduct the test using a given test statistic to obtain the p-value. What do we mean by this? Appropriate or giving or using a given test statistic in we will not be discussing different statistics that we use in terms of hypothesis. The reason is because we are not in statistics classroom. Okay? Because we are not in statistics classroom, we will not be discussing different statistics that we use. Just for us, like in the Department of Statistics, something that this thing that we call ANOVA, okay, is a course that is taken at the undergraduate level by third-year students. ANOVA alone. I hope you know what I'm saying. And in that course, ANOVA is introduced, the case theory is introduced, everything about it is introduced, and one knows everything about it. So it is not for us to begin now to discuss them one after the other. What is this test statistic? What is that test statistic? But the summary is that for a test to be conducted, there is what you know as the test statistic that is used. Like test involving a single proportion has its own test statistic. Test involving difference of two proportions has its own test statistic. Test involving a single mean has its own test statistic, and so on and so forth. But these days, we don't even see someone that does statistical analysis with calculator any longer. What do we use? We use statistical software to do test of hypothesis. And when we use statistical software, those software they have these test statistics inbuilt in them. All that they need from us is our data. Once we supply the data to the particular software, it goes inside the system, brings up its own the test statistic which is inbuilt in that software, uses it, finishes the test, and then supplies the results as the output. Is that clear? But it's important that we know. For us in statistics, everything that the software is doing inside, we know all of them. We know the test statistic that it has applied, and we know the procedure it has taken. And when it is bringing results, we know what happened for that result to come out. But for someone who is not in statistics, that is not needed. What is important is that this is the result that I have, and I should be able to interpret it. Is that clear? The next step is to compare the p-value obtained with the specified level of significance, and that I have said before. Maybe I want to test at 5% level of significance. The software gives me a particular p-value. It is now left for me to compare that p-value with the what? With the level of significance I have. And what is the comparison? Any p-value that is less than the stated level of significance leads to what? Rejection of the null hypothesis. While any p-value that is greater than the stated level of significance leads to what? Non-rejection of the what? Null hypothesis. Is that clear? I hope it's clear. I will say it in a different way. I said, if the p-value is less than the level of significance, it means there is significance, which is in favor of the alternative hypothesis. But if the p-value is greater than the level of significance, it means there is non-significance, which is in support of the null hypothesis. Is it clear now? The lower is not the better. It depends on the purpose of your research. There are some research that maybe you are expecting to have nullity, no significance. In such a situation, the higher leads to what? No significance. But at the same time, when we begin to look at the issue of better or no better in research, sometimes it is confusing, because what we want is to conduct the research and then report the results. Everything that one sees in research is a result. Maybe you are interested in checking how this, maybe if this affects, and at the end of the day, you saw that it does not affect. It is a result, and what you need to do is to report it. I don't know if it's understood. The essence of it is that somebody else will see the output and now knows that, okay, this does not actually affect. The person will not go into that again. And if there is anything that the person wants to do, bringing to mind or putting into consideration that affects, the person has now known, and he will not do that on the basis that it affects. So it is still an output, it's a result. Sometimes some persons will want the result to be in a particular way, and if it is not in that way, that person is really crying that I have not done anything, and because this will not be accepted, I don't know what to do. And that is what leads some people into fraud. They will tell you, is there nothing that can be done so that this result will be like this? It is fraud. You don't change the results because you want the result to be in a particular way. Rather, you report what you have seen and then discuss it with your supervisor. If your supervisor says no, that we cannot present this kind of result, what it implies is that some other things have to be done, but not to change that result. What are the things that will be done? Probably the purpose of the research may change, even though I know, yes, some people, especially when you are doing a degree-based research, you will see it as a setback, that maybe this man or this woman doesn't want me to graduate. You can imagine I have got to this level and he says or she says I should go back to the fair. I should change this, I should change that. But all of them are part of the research. And whichever one that you see, we will have to accept it. And you are still at liberty to say no, that I will not go back. Let us report this. So long as it is agreed upon, it can be reported. But the one I will not take is that you begin to change so that it will conform to the way you want it. That one is academic fraud, and that cannot be encouraged. Then the number 5, decide whether or not, okay, I have talked about that. Number 6 is make conclusion about the test based on the decision made in step 5. When you have compared, is the p-value less than the level of significance? If it is yes, there is significance. If it is no, there is no significance. So make your conclusion. based on that the comparison. I'm sure that is understood. So that is all about. These are the steps that we will go through in any test of hypothesis that one is embarking upon. When you have done those step 1 to step 6 are the itemized, you have concluded the test of hypothesis. Every other thing that is remaining is for you to discuss your results. You sit down and begin to discuss your results. And the discussion of results brings in so many things. You can discuss it and continue to discuss it to bring in even in some researches, the discussion of results even involves what people had said before in that particular subject. Is it not so? You can even begin to mention that this result you have got is in line with this other ABC 2000 and this, in line with XYZ 2000 and this. You understand? Sometimes it will not be in line, and you will still be careful and then polite enough to say that this result is not what in line with what XYZ reported in 2025. Be polite to present it. And when you have presented it, say in that discussion, you may begin to look at it again and probably begin to see what would have led to that. It is still part of the discussion. I'm sure it's understood. So all of them we need to do to be able to do what? Give a sufficient reason why someone will be able to accept the result that we have presented. So having done that, we are done with test of hypothesis. We go into measures of association. Measures of association. And these involve two aspects. And what are them? Regression and the correlation. They are the two measures of association. What do? They try to measure association between variables, relationships between variables. That is what they try to do. And we are going to discuss them one after the other. And the first we are going to be looking at is the regression analysis. Regression analysis. What is regression analysis? Regression analysis is a statistical analysis that is used to measure association by determining the nature of relationship that exists among variables. Regression analysis measures the nature of relationship that exists amongst variables. Is that clear? It tries to look at, there are certain variables that have linear relationship. We know what a linear is. Linear is a straight line. There are some variables that have a straight line relationship. Even while there are some variables that have non-straight line relationship, like a curved relationship. Is that clear? Good. So even when we have linear relationship, there are some variables, even though they have a linear relationship, but this linear relationship it may be inverse. What do we mean by inverse? As one is moving up, the other one is linearly doing what? Coming down. That is the relationship, the nature of the relationship. There are some that have a direct relationship. What is direct relationship or positive relationship? As one is increasing, the other one is what? Increasing in the same direction. So when we have that, there are different kinds of what? Linear relationship. There's yet another type of linear relationship. And which one is this? As one variable is increasing, the other one remains constant. Which means, in this case, there is no relationship between them. As one continues to increase, this one is not shifting. It's not going down, it's not increasing, it remains the same thing. In such a situation, there is no relationship between the variables. Is that clear? So when we have Two types of relationship that we measure in regression are linear relationship and non-linear relationship. There are different types of regression analysis. I don't know if our, what do they call it? Um, Concentration span. It appears it has, you need to go for break. While I'm thinking otherwise. If our attention span has been exceeded, maybe I will ask us to stand, stretch ourselves, and sit down so that it will come back. We will go on break very soon, okay? But what I'm trying to do, I want to call us back. Let us continue so that we still have a long way to go. Yes, and we must end today. So let's continue. What am I saying? I have said that there are different types of I have said two types of regression analysis: linear regression and non-linear regression. Is that clear? Then when we come to linear regression, there are different kinds of linear regression, or let us put it this way, kinds of regression, not specific to linear or non-linear, but two different kinds of regression. And what are them? In every regression analysis, there is a variable that we know as a response variable, while we have other variables that we know as predictor variables. So there are two kinds of variables in every regression analysis. One is what? Response variables. And there are different names for response variables. Response variables can as well be known as dependent variables. I said that response variables can be known as dependent variables. They can as well be known as predicted variables. They can as well be known as predicted variables. Is that taken? Good. There are different names that response variables can be used. Then they can as well be known as the regressor. The response variables are the regressor. I have mentioned the four names: response variables, dependent variables, regressor, and the predicted variables. So the other type of variables are known as what? The independent variable. Do you understand that? The independent variable or variables, also known as the regressand, also known as the regressand, also known as the predictor variables, also known as the predictor variables. Did you get what I said? It's different from what you have. What is the difference? Okay, you are correct. The regressor, because it is the predictor variables that will force whatever the response variables will be. Sorry about that. The regressand is the response variable, while the regressor is the independent variable, or the predictor variable, or the explanatory variable. All of them are the names given for the independent variable. It is the explanatory variable, it is the predictor variable, it is the independent variable, it is the regressor. Is that clear? Good. Now, I want to say at this point that a regression analysis may be simple or multiple. A regression analysis may be simple or multiple. When is it simple? It is simple when it has only one independent variable. When it has only one independent variable, which we have noted to be explanatory variable or the regressor. When it is only one in a regression, we say we have a simple regression analysis. Is that clear? But when we have more than one independent variable, we say it is what? A multiple regression analysis. Is that clear? At this point, I will have to say that in every regression analysis, the number of the response variables is always one. Did you hear that? I said in every regression analysis, at least at this point, because we are not discussing multivariate analysis. If we go into that, we have multivariate regression that has many independent variables. But the ones you do, measuring in all the ones that you see in your analysis, there's always one dependent variable, while there will be many independent variables. So the number of independent variables determines whether the regression is simple or multiple. When we have many of them, more than one of them, it becomes multiple. When we have only one, it becomes simple. But for the response variable, it's always what? One. There is an example there, but we will not,
Slide number.
going to make a jump. Don't worry, I want to make a jump. Let's go to slide number 48.
Okay.
Okay. That means there is difference.
No. 48. No, I saw 48. And 47.
Okay.
Okay, 47.
Okay, that is all that we can say about regression analysis, because what I said in the test of hypothesis, I'm still saying here. We are not expected to get our calculator and get our notes and begin to solve them. Whenever we have a data set, we can subject it to analysis by the use of statistical software. Do we understand? And as a result, all that we are going to be seeing is the output, the results. And once we see the output, we will report it and then discuss it. And that is the end of that. So we will not go into the rigor of trying to maybe solve a regression analysis problem. So having said that, we will jump to correlation, which is the second arm of measures of association. While regression analysis discusses the nature of relationship that exists between variables, correlation measures the degree of the relationship. It measures the degree or the extent of the relationship. That's what correlation does. It tells us these two variables are related. Okay? The question correlation answers is what? To what extent are they related? That's what we use correlation analysis to discuss. So that is why when you subject maybe a work to correlation, you begin to see different values. I will have to say at this point that This, which we have called correlation, so many persons has carried out works in the past to try to estimate what correlation between variables can be. But before we go into those details, there are different kinds of correlation. Number one is when we have correlation between one variable and another variable, okay, which we call bivariate correlation. Is the correlation analysis between two variables, this versus that. How are they related? What is the degree of the relationship between two variables? So when we have a correlation between two variables, we call it bivariate what? Correlation. Then the second type of correlation is correlation between two variables in the presence of another variable. The presence of this other variable is likely going to affect the what? The relationship between these two variables. It may affect their relationship adversely, or it may affect it, or that is positively. I hope it's understood. To the extent that when we determine the extent of their relationship, the relationship between these two variables, maybe when we have done that, we got the value of 0.8 to be the degree of their relationship. But when we now find the same relationship between the same two variables in the presence of another variable, it is possible that the relationship between those two variables will now drop to 0.57. It is equally possible that it may increase to 0.95. Do you understand? What it implies is that this other variable that is present as we measure their relationship has affected their relationship. So when we are discussing that, we say we are discussing partial correlation. Partial correlation is the correlation between two variables in the presence of another variable. So that relationship is not pure, it is partial, because that other variable that is present is affecting whatever thing that we are seeing. So it is partial correlation. Then the third type of correlation is when we are interested in looking at the relationship between one variable and a set of other variables. Is that clear? The relationship between only one variable and a set of what? Other variables. When we are discussing that, we say we are discussing multiple correlation. It's multiple correlation. Is that clear? Then the last type of correlation is when we are discussing the degree of relationship between one set of variables and another set of variables. So it is now a set versus what? Another set. Is that clear? When we are discussing this type of correlation, we say that we are discussing canonical correlation. It's canonical correlation. I'm sure it's understood. But in all of this, the commonest type of correlation, which is almost the one that we mostly see in our various researches, is what? The bivariate correlation. Is that clear? It's the bivariate correlation. And because of that, I will center on that bivariate correlation to say that the correlation values in bivariate correlation range between -1 and +1. The highest correlation value is 1, and the smallest bivariate correlation value is what? -1. So, bivariate correlation has values ranging from -1 to where? To +1. There is no bivariate correlation value that is more than 1. And there is no bivariate correlation value that is lower than what? -1. I'm sure that is understood as well. Now we use these values to do what? To describe the degree of the relationship that exists between variables. When it is close to -1, we will say that there is a perfect negative what? Relationship between the variables. Perfect, because it is close to 1, but it is minus, therefore it is what? Negative, which means as one variable is increasing, the other one is perfectly what? Decreasing. So there is a perfect negative relationship between the variables. Is that clear? The issue of a score, there's no consensus. It depends on where you are and depends on the school of thought. Some persons may say any correlation value from 0.7, do you understand, should be seen to be perfect. Others will say any correlation value that is from 0.8 should be regarded to be what? Perfect. Do you understand? So there is no consensus to that. But the best bet, or maybe how to discuss it at this point and to be sure that we have not justice to that without introducing an error, is to say when it is close to -1. So how close it is to -1 is now depends on what you have made out of it. Do you understand? So when it is close to -1, there is a perfect negative relationship. When it is close to 1, there is a perfect positive relationship. Is that clear? Then when it is close to 0.5, when it is close to 0.5, one may say that there is a good positive relationship, and when it is close to -0.5, one may say there is a good negative relationship. When it is close to 0, when it is close to 0 on the positive side, okay, one may say that there is a poor positive relationship. But when it is close to 0 on the negative side, one will say that there is what? A poor negative relationship. Is that clear? Then sometimes in some quarters, the issue of perfect may be replaced with strong. Okay? The issue of perfect may be replaced with what? Strong. Some persons may be using strong negative and strong positive in place of perfect positive and perfect negative. Is that clear? There's someone that was asking a question here. Which one do you want me to repeat? I should repeat everything I've been saying since morning. Tell me what to repeat. Okay, the last one I said when it is close to 0 on the positive side. When it is close to 0 on the positive side, we will say that there is a poor positive relationship. When it is close to 0 on the negative side, we will say that there is a poor negative what? Relationship. Now, let me say the last thing on the correlation. And what is that last thing? The correlation values that we normally report are correlation values that are obtained from a sample. We know that because our participants in the research are always what? Samples. So there are correlation values obtained from a sample, which means they are estimated correlation values. Is that clear? And we are not here to begin to discuss the population correlation. But what we are discussing, which we normally report in our work, is what? Sample correlation, which in other words is known as estimated correlation. And there are different authors that have tried to obtain a means of estimating that population correlation. And the earliest work, the first work that was done to obtain an estimator or a means of estimating the population correlation was done by a mathematician that we know as Pearson. And that is why that he has a method of correlation which you know as Pearson's product moment correlation coefficient. Okay? If you like, if you call it Pearson, someone called it Pearson square. Okay, I will take that, but I don't know where it's coming from. I know it as Pearson's product moment correlation coefficient. Okay? Apart from that method, there are still other authors that came up with other methods. Of course, the Pearson's product moment correlation coefficient is arguably the most popular correlation coefficient, arguably the most popular method of estimating the population correlation. Is that clear? But apart from that, there are still other methods. The second author that did a work on correlation, estimating correlation, is Spearman. And he came up with what we know as Spearman's rank correlation coefficient. Okay? While Pearson's product moment correlation coefficient uses the actual values to obtain its correlation coefficient, Spearman says no, instead of using the actual value, let us rank the values. He now uses the ranks of those values. You know how to rank a value. We rank a value by either arranging it in ascending order or arranging it in descending order, such that if I see values in the first variable, I will be seeing it. Maybe the first value is the 20th highest value. So it will take the rank of 20 instead of the actual value. Excuse me. Instead of the actual value. I hope it's understood. So, one more. Thank you very much. But, yes, I know. I know. And I appreciate that. While the product moment correlation coefficient uses the actual values, while Spearman uses the ranks. Instead of using the actual values, get their ranks and use their ranks. And when we look at two of them in statistics, we call it Spearman Pearson's product moment correlation coefficient. We call it a parametric method of estimating the correlation coefficient. While the Spearman's own, we call it a non-parametric method of estimating the product, the correlation coefficient. We still have one more person that did a work on correlation, but we are not going to discuss that. There was one of the mathematicians in the past that goes by the name Tau, T-A-U. He has what we know as, in fact, he was not the only person that did the work. The person that did the work was actually Kendall, a mathematician, and it is called Kendall's Tau. And that is equally a measure of correlation, but I don't know what happened to their correlation coefficient, that it is not very well known. It is known only among the statisticians. When you leave statisticians, you will not hear of Kendall's Tau any other place. Maybe they didn't pray very well before they came up with that correlation coefficient. Both of them are good. Both of them are good, and in most cases, even though when you use the same data sets, when you employ the two methods on the same data set, you will not get exactly the same value. Okay? But there is only one thing that two of them do. do. And what is that? If you are reporting a perfect positive correlation coefficient using Spearman's product moment, Pearson's product moment correlation coefficient, it is the same that you are going to report when you are using Spearman's rand correlation coefficient. Do you understand? That is to say, maybe you have used Pearson's method and you got a correlation value of 0.82. If you use the Spearman's own, you may still get a value of maybe 0.79, which is closely related to 0.82. Do you understand? To the extent that what you have generally concluded with one, you will probably conclude it with the other, even though two of them may not give exactly the same value. Is that clear? But there's something we know in statistics generally, which is true. Parametric methods are stronger, more efficient than non-parametric methods. We have established here that Pearson's method is a parametric method, while Spearman's method is non-parametric method. So going by what I have just said now, one will always know, expect the parametric method to be more efficient than the non-parametric, thereby saying that Pearson's method should be better than Spearman's method. That is a discussion for another day. Okay, this is by my time, 1:50. So I want us to break at this point. How many minutes?
30 minutes.
So, like I said, by my time here is 1:50. So we are going on 30 minutes break. We are going to return by 2:20. 20 minutes past 2. We return. Thank you. And see you then.
Thank you.